I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss logarithmic equations, and our focus is to explore the extraneous roots. There are many videos on this topic in my channel. However, this one will discuss four very important questions which are normally seen in any test paper. So, this particular video, especially for our IB students to practice for their own test. I hope all of you will enjoy it. Well, while solving the questions, understand logarithmic properties, solve logarithmic equations, check for extraneous roots, and that will help you to prepare for your own test. Let me also thank all the viewers and subscribers for giving us a lot of encouragement with their comments, donations, and suggestions. Keep doing it. We want to reach millions by your contribution. Keep supporting us. For any suggestions, you can always contact us on the email. Now let's begin with the set of questions which we have today. Four of them right there before you. As you can clearly see, the first one, log to the base 4 x minus 3 plus log to the base 4 x plus 3 equals to 2. Apply the properties. So here the product of x minus 3 and x plus 3 will help you solve the question. The next one, we have log x to the power of 4, slightly different from the first one. And then question number 3, we have x to the power of log of x within square root. And question number 5 has a radical. We have fifth root, right? So now let's solve them one by one. This is a very good variety and I'm sure you all will love it. Well, in case you want to learn directly from me, feel free to send an email on the address globalmathinstitute@gmail.com. Let's begin with our solutions now. So the question here is to solve the equation log to the base 4 of x minus 3 plus log to the base 4 of x plus 3 equals to 2. Now, as you know about logarithmic characteristics, the argument x minus 3 or x plus 3 should be always greater than 0, right? So, if I put x minus 3 as greater than 0, I get x is greater than 3, correct? So, that becomes the restriction, correct? From the x plus 3, if you put greater than 0, you get x is greater than minus 3. However, what prevails is that x should be greater than 3. So that becomes a restriction on this particular equation. And if your answer is below 3, it is considered to be extraneous root. You get the whole idea. So the concept, how do we identify extraneous root, basically depends on defining the domain. Clear? Now let's begin with our solution. Applying the properties, we could club them as log to the base 4, same base, so we'll multiply x minus 3 with x plus 3, correct? Equals to 2. Now that results into writing it as 4 to the power of 2, right? So we could write x minus 3 times x plus 3. You could also expand this as x square minus 3 square at this moment, 4 to the power of 2, correct? So let me just expand it now. So we get a square minus b square, right, which is x. Let me write 3 square first, right, equals to 4 square, which is 16. And we can say x squared is equals to 16 plus 9, which is 3 squared. And so what do we get? Well, clearly we get x squared equals to 9 plus 16, which is 25. And when you do square root, you have to write plus and minus, right? 25. And that gives you two solutions, which is x is equals to plus and minus 5. Now, since we know that x has to be greater than 3, So we have one answer, which is x is equals to plus 5. So that is the correct answer. And then we have x equals to minus 5, which is extraneous. Makes sense? So the correct solution is only x plus 5 and not x equals to minus 5. So that is how we'll get extraneous roots in these solutions. Reason is very clear. So when you square, right, you incorporate errors, right? Okay. So key is check the domain. Let's now continue with the second question. I hope this concept is absolutely clear. Now here we have similar kind of situation. You may actually pause the video answer. So let's look into this question, which is log to the base 10 x to the power of 4 minus log to the base 10 of 3 equals to log to the base 10 of 3x squared. Right. So you can bring all the terms together and then equate. You could do that. So we have log x to the power of 4 over 3, right, equals to log 3x squared. Now, in this case, x has to be greater than 0. No, both are squares. You see that? Since both are squares, we have one restriction that x is not equal to 0. You get the idea? Because x to the power of 4 and x squared will make negative things positive. So that is what it is. Okay. So now both logs, we could rewrite this as x to the power of 4 over 3 is equals to 3x squared, right? Cross multiplies, we get x to the power of 4 equals to 3 times 3, which is 9x squared. Bring the terms together and then solve. So you can actually now pause the video, do the needful, right? Now, and then continue with the solution. Well, let's bring the terms together. X to the power of 4 minus 9x squared equals to 0. So x squared is common. So we get x squared minus 9 equals to 0. Now that gives you a couple of solutions, right? So what could be the solutions? X is equal to 0 and also equals to plus 3 and minus 3. So there are three solutions. So in this case, remember the extraneous root is what? Is x equals to 0, correct? And what is the solution? Solution is x equals to plus as well as minus 3. You get the idea. So we have two solutions to this particular equation. I'm highlighting all the solutions which are the correct ones. And so there's no confusion, right? Extraneous root is x equals to 0. So that is not in the domain. Perfect. So I hope you're enjoying this journey of learning. In case you really want to do very well, in that case, you can always send an email on the address given. Well, let's look into the next question. Slightly different, new type of a question. Variety is what we are interested in sharing with you. So we have square root of x to the power of log x, right, equals to 100. So can you please solve this question now? Well, what we could do is we could square both sides. So we get x to the power of log x equals to 100 square, right? So we just squared both sides and got this. Now, how do we solve the question? Now, this is a tricky part. We can take log on both the sides. So, take log on both sides means it'll be log x to the power of log x, right? Equals to log of 100 to the power of 2, which is 10 to the power of 4, right? Now, what is log x to the power of log x? It is equal to log x times log x. Do you see that is very critical to understand? And this part, 100 to the power of 2 is 10 to the power of 4, which is equal to 4. Is that clear to you? So this is something new which you may learn at this stage, right? Okay, so give a thumbs up if you're really liking these types of solutions. Perfect. So we have log of x whole square, that means, correct, as equal to 4, and clearly log of x will be equal to plus and minus square root of 4, which gives you two answers, which is plus and minus 2. And clearly here we know x has to be greater than 0, right? So negative 2 is extraneous. So we can write extraneous root is x equals to minus 2, and the solution is x equals to plus 2. Is that clear to you? Again, I'm highlighting the solution this time so that you're absolutely clear what is the right solution. Perfect. So, once again, in case you want absolute success and gain confidence in what you're trying to do in maths, please follow us or send an email on this particular address. Now, here's the last question for you. Knowing all the strategies, this becomes a very critical question. Log fifth root of x squared minus 15x is equals to 2 over 5. As you know, our website and the YouTube channel provides you with amazing examples which really help you to do far, far better, whether you're a normal student or IB student or AP student, whatever, right? It works for all of you. This website is, this channel is at least 15 years old now. Perfect. Now let's try to solve this question, which is log fifth root of x squared minus 15x equals to 2 over 5. So let's write down it in exponential form, right? So we have fifth root of x squared minus 15x equals to 10 to the power of 2 over 5. Makes sense? Now we can take to the power of 5. So we get x squared minus 15x equals to 10 to the power of 2 over 5 to the power of 5. Makes sense, right? So now it is simple, right? We can rewrite this as x squared minus 15x equals to 10 to the power of 2, right? 5 and 5 cancel, which is 100, right? Bringing all of them together gives you a quadratic equation, and factoring will give you the solution. We need product of minus 100, sum of minus 15, 20 and 5 will work for us, correct? So x plus 20 times x minus 5 equals to 0. That gives you x equals to minus 20. Should have been x equals to minus 20 and 5 plus, right? Because it was minus 15, correct? So it should be minus 20 and x equals to plus 5. That will give me minus 15. So it will be x equals to plus 20 and x equals to minus 5. Make sense? Perfect. Now, again, looking into the strategies, what is valid and what is not valid. So within fifth root, it could be any answer, correct? Okay, so now let's look into what is not valid here. So clearly we have x squared minus 15x. That should be greater than 0, right? You could factor and you can write this as x minus 15 is greater than 0. So you could actually do it by sketching a graph, parabola opening upwards, and you see this particular parabola has got zeros at x equals to 0 and 15, right? So the answer which is valid is basically on the right side of 15 it is positive, right? And even on the left side of 0 it is positive. You get the idea. So in this particular case, both the answers are correct. So we have a solution here that x equals to minus 5 as well as 20. You get the idea. We really do not have any extraneous root here. You can clearly see here if x is minus 5, if I substitute that here, in that case it is still positive within the radical sign. And for plus 20 also it is positive, as you can see here, right? So both are the solution. Very, very important question. Many times students write minus 5 as an extraneous root, which is not the case, right? So let me rewrite. Here we do not have any extraneous root, right? So no extraneous root. I hope that makes sense. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.